Hello, this is Britt Caswell with another example video. In this video, I'm covering example 1 from section 3-1 in the SavvasRealize Algebra 2 textbook. In this example, we are looking at classifying polynomials. So this opening question actually asks for a lot of information. Okay, so I want to go through and make sure that you guys understand what each definition is. So a polynomial written in standard form has two features. Okay, so I'm going to write standard form here. The first feature is that all like terms are collected. So you can't have like two square terms in there, or you can't have two constants. You have to collect it if there's any like terms. The other thing is that it has to be written with exponents in descending order. So what that means is that the largest exponent has to go first, and then the smallest exponent has to go last. So let's go ahead and let's look at putting this in standard form. So my highest exponent is this cubic term here, so I'm going to write 2x cubed first. I like to cross them out as I go because I feel like it makes it easier to see. The next term down is 4x, that's my linear term, so I'm going to put minus 4x, and then my constant goes last, which is that 9. Now if you check, you want to make sure that there's only one copy of each exponent. Alright, there's only one cubic term or only one linear term. And in this case I don't have to collect any like terms, so this is the standard form. Now the leading coefficient is the first number that shows up. So my leading coefficient is 2. Next up comes the degree. Alright, it's not asking if this polynomial went to college. Alright, the degree is the exponent of that leading term. So it's the highest exponent that we have. And the reason why we care about, oh, I can't spell exponent while I talk apparently. The reason why we care about this first term so much, the leading coefficient and the highest exponent, is these have the biggest impact on the polynomial. So as we get to really large numbers, say we get up to 400 million, this 2x cubed is going to have a way bigger impact on the graph than this linear term or this constant. Alright? Now the number of terms, I'm going to define term. A term is a monomial which is usually separated by addition or subtraction. Alright, so when we talk about the number of terms, we are talking about how many things are being separated by addition or subtraction. So there's 1 term, 2 term, 3 terms. So this expression has 3 terms. Alrighty, so let's go ahead and let's try that with another one. So first is writing this in standard form. So we need to write it with our exponents counting down, right? So I have a negative 3x to the 4th here. The next smallest is negative 5x cubed. Next smallest is a positive 2x, and then a positive 6. So there's standard form. Our leading coefficient, I'm going to say LC, is that very first number that shows up, which is -3. Sorry for going up and down. I'm looking for what colors I was using. My degree is that highest exponent, so this is a degree 4. And the number of terms there's 1, 2, 3, 4 terms in this. Alrighty, so let's try this again. So standard form, counting down, I have a 2x to the 6th as my highest exponent. I have an x to the 5th. I have a -3x to the 4th. I have a cubic term and my linear term. So my leading coefficient is that very first number, which is a 2. My degree is that highest exponent, which is a 6. And then in terms of the number of terms, I have 1, 2, 3, 4, 5. So there we have it. That is a big part of how we classify polynomials. The only thing I would include here, which Savvas doesn't, is a couple of expressions for describing a polynomial with the number of terms. So remember, a monomial is 1 term. Mono means 1. A binomial is 2 terms. And a trinomial is 3 terms. So those are some specialty words that Savvas doesn't tell you about, really, I don't think. But we use them all the time in math, so I wanted to make sure you've seen them before. Alrighty, until next time.